Hello everyone, this is Shubham and I'll be discussing about a polygon. So let us understand what is a polygon. Now see, polygon comes from two words. The first is the poly and the second is gon. Now if we were to understand the term polygon, poly means many and gon means sides. Basically any figure that has many sides is called a polygon. But wait, there is another definition here. If you look into this, a polygon is a simple closed figure. The first thing that we learn is it is a closed figure made by only line segments. So there are two terms that we need to discuss. For the first is a closed figure and the second is a line segment. Now let us see. Let's draw a figure here. Let's make it a figure and we'll draw a polygon here. And we'll also draw another polygon, another figure actually. And let's take this. Now you can see this in this, the boundaries are enclosed, correct? Means this is an enclosed boundary. But if you look into this is an open boundary. Therefore, this will be my closed figure, closed figure, and this will be my open figure. These two both are made up of sides, but this is my polygon, whereas this is not a polygon. Now, what is a line segment? Let us first understand what is a line. Uh, a line is basically a collection of dots. This is a line. This is basically a collection of dots. There is a dot there and here dot the dots. I will represent the dots here with this. This is basically a collection of dots that can be extended to infinity. So we denote this by arrow sign. Now this is going to infinity. That this shows that any point on infinity is undefined. It cannot be measured. So if we have break one of its side, like if I break this side and I point it at A, then I can show this by one fixed end and the second end will be my going to infinity. Now this is my line and this will be my ray. Ray is a line where one end is fixed and the other end is not fixed. Means the other end is independent to go to the infinity. Now, if you talk about a line segment, what is a line segment? Segment basically it is a part of a line. So if this is only one point now, but I cannot measure any distance from this point unless we fix that point because this line is going towards the infinity and any point of on infinity is undefined. So if we take another point here B, and this point is a definite point, means we can measure the distance between A and B. If I show this in here, this is my B. Now basically this AB is a part of this AB. This AB is a part of this line. Therefore, we will say it as line segment. Line segment. Okay. Now, if we talk about a polygon, again, let's come back to the polygon. Basically, polygon was what? A simple closed figure made up of only line segment. Now, this is line segment because I'm fixing both the ends. This is another line segment. Let's draw a straight line segment again, again, and let's finish it. Okay, now you can see there are 5 line segments. 1, 2, 3, 4, and 5. So now there are 5 line segments. Now what do you understand by this? This is a polygon. This is a polygon. Now let's look into the components of a polygon. Now the components of a polygon are its vertices, its sides, angles, now in also the diagonals. Now see, this is a line segment, correct? And when the two line segments are meeting at a point, like if I have to draw, this is a line segment, or you can also use a ray, but now we are talking about line segments only. And this is line segment A, B, and C. Here A, B, and C, B are meeting at C. Therefore, C will be the vertex. Correct? Again, now look in this figure. This is my line segment. This is another line segment. And they both are meeting at which point? At D. Therefore, this point will be my vertex. Correct? Now, what is the vertices? Well, the vertices of a polygon are formed when two adjacent sides of a polygon meet. Just a minute. Okay. So we were discussing about the vertices. Like these, this is a line. The two lines where they meet. Sorry, these are the two lines that are meeting at point D. So point D will be the vertices. Now, when we talk about the adjacent vertices, now see, adjacent vertices are vertices that have a side in common. Now this is a side. Now let's say this is an enclosed figure. Let's enclose it first. Now this is a side AB. This has two ends. Okay. In an enclosed figure, the vertices which have a common side are the adjacent vertices. So this and this will be called as adjacent vertices. Okay. Now let's talk about what is a side. A side is basically, from here you can understand, side of a polygon the line are the line segments that form the polygon. This is one of the definition that you can get, and some other definition what would be. So based on the understanding, if I were to define a side of a polygon, like this is a polygon now. So the line connecting two adjacent vertices. Now here, if you see, these two are the adjacent vertices. Okay. Now the line connecting the adjacent vertices is the side. And this is the line that is connecting the adjacent vertices. This is the line. Now this line it will be my vertices, vertex. And sorry, this line would be my side. Now similarly, these two are the adjacent vertices. So this line will be the side. Okay. Now what is the diagonal? So understand this. Now this is a vertex, and these are the two adjacent vertices of this vertex. Now, what are the non-adjacent vertices of this vertex? Suppose I'm talking about this vertex. Now, what are the non-adjacent vertex? Now, this is one of them. This is another one of them. So, if you draw a line from here to here or to here. Sorry, this went wrong. To here to in here. So now the line that connects the two non-adjacent vertex. These two are my non. I'll just write in short vertex. Now this line and this line will be my diagonal. Okay. Similarly, if you look into the figure, if you look in this figure, you can see this E is a vertex and this C and this P are the non-adjacent vertex. The line that connects E from C and the line that connects E from B are the diagonals. Now look at the definition. A diagonal of a polygon, a diagonal of a polygon are the line segments that join the non-adjacent vertices of a polygon. So what are the examples like this? There are many examples. BE, CE, AD, AB, and AC. So these are the diagonals of a polygon. Now we'll talk about the angle. What is an angle? First, understand the meaning of angle. When the two, sorry. Now when the two line segments, the two rays are meeting, this is my vertex. Let's take it as line segment A, B, and this is my C. Now here, again, the space between the two line segments measured in degree, this is my angle. Okay. Now in case of a polygon, exterior angle, there are two types of angle. The first is the exterior angle, the second is the interior angle. The first, the interior angle simply means interior angles are the angles that are formed between two adjacent sides. So if I were to draw a polygon of five sides, that is a pentagon, now this side, these two sides will produce an angle. This is my interior angle. Now, what if I extend one of the sides and form another angle? Like this is my, take this is my another polygon, a triangle. If I extend one of the side here, there will be an angle formed, and this angle will be my exterior angle. Okay. Now the examples, look at, if you look into this polygon, what are the examples of an exterior angle? Like this C, D, and let's take this point as P. So C, D, P will be my one of the exterior angle. What are other? Let's take this angle as Q. So D, C, Q will be another exterior angle. Okay. Now if you name the angle, like if you name the angle like this is my angle 1, this is my angle 2. So what will be my external angles? This angle 1, angle 2, this angle 3, this angle 4, and this angle 5. These are my exterior angle. What are the interior angles? This angle CDE, this angle DCB, this angle CDCBA, this angle BAE, and this angle AED. So we have gone through the concept of a polygon. Let's understand the types of polygon. There are two types of polygon. The first is the regular polygon. What is a regular polygon? There are two criteria for a polygon to be a regular. The first is the line. The sides of all the sides of a polygon should be equilateral, means every side should be an equal length. The second is the all interior angles are equal, means if you measure all the angles of a polygon, all angles should be an equal. Now, if you look into this diagram, let's take this point as A, this point as B, C, D, E. From here we can understand that A, B is equal to B, C is equal to C, D is equal to D, E is equal to E, A. Now since all the sides are equal, the first criteria is met. What about the second one? If you look at all the angles, this is 108, 108, 108, 108, and 108. Actually, the sum of all the angles of a pentagon is equal to 540 degree. So if you divide this by 5, it will be 108 degree. So if all the angles of an of a pentagon is 108 degree, then this is will be my regular polygon. Similarly, if you talk about an irregular polygon, now when the sides are not equal or the angles of the polygon are not equal, then this will be my irregular polygon. Okay, so look at this. Now let's draw another example. What about a rectangle? This is my rectangle. Now here, what is happening now? The opposite sides are equal, but are all sides equal? No. Therefore, this will not be my polygon. Even though the angles are equal, all the angles of the rectangle are 90 degrees, but it is not a equilateral. It is not a regular polygon. Okay, both the criteria should be matched. Now, let's talk about the two types of irregular polygon. First is the convex, and the second is the concave. What is the meaning of this? A convex polygon is a polygon in which all interior angle measure less than 180 degree, whereas a concave polygon is a polygon in which at least one interior angle is measured is 180 degree. If you look at the definition, if you look at the example, if I draw a figure like this is a figure. In this figure, you can see clearly see this angle is 100 degree. This is 40 degree. This is 100, and this is 120. So 200, 320, 360. So this is my 360 degree, and no angle is greater than 180 degree. Means every angle is less than 180 degree. Means this is my convex polygon. Now, what about a concave? You will see a cave. If you have to understand now, like this is a cave. Okay, you enter into this, and this is your cave. Now, so this is how you can understand a concave, where you can see this type of figures. Here, this is a cave-like structure. So here, all the angles are will be 180 less than 180 degree, but one or two angles or max three angles. It depends upon the construction of the polygon. One of the angle will be greater than 180 degree. It will be greater than 180 degree, then it will be a concave polygon. Now, can an irregular polygon be a can an irregular polygon have all the angles equal, or can it be like, is it necessary for every irregular polygon to have all the angles equal? I will leave it to you, and we'll move to the next topic. Let's understand about some of the figures. Now, if you look into the first question, uh, this question in this it says you have to understand that is it a regular polygon or a irregular polygon. So when you talked about a regular polygon, this is my regular polygon, this is my regular, and this is my irregular polygon. So what was the basic definition of a regular and irregular? So in regular polygon, there are two criteria. The first was the sides are equal. All sides are equal. And the second one was all interior angle should be equal. What about an irregular? Not equal. What is the actual meaning of this? Suppose if I draw a irregular polygon like this, let's draw a irregular polygon of equal sides. This is my irregular polygon of equal sides. All sides in this polygon are equal. But is this a regular polygon? If you look at the measure into the angles are not equal. And this is my one of the example of a concave polygon. Okay, now here all the sides, even though all the sides are equal to one another, but all the angles are not equal. So it is an example of irregular polygon. Now, let us come to the question. In the first question, you can clearly see that look into this angle. If you look at this side and this side, these two are equal, but this is not equal. Means this is my irregular. What about this? Since all the sides are equal and it is a convex polygon, so it is my regular. All the sides and all the angles are equal. Again, this is same. This is my regular. If you look into this, this side and this sides are these two sides are not equal. Again, this side and this side is not equal. Also, if you look into the angle, if you look at the angle, then you can clearly see that this angle okay, minute, looking at. If you look at here, this angle, if you see closely, this is my around 90 degree, okay, but this is more than 90 degree, correct? So therefore, this is my irregular. Again, if you have to find about this, you can see that this side and this side is not equal. Again, this side and this side is not equal. So again, irregular. Okay, this is how you measure the angles and sides. Now state whether the given statements are true or false. For the statement that are false, write the correct statement. A rectangle is a regular polygon. Okay, we have already discussed about it. I will leave it to you. Is a rectangle a regular polygon? If not, then tell me why in the comment section. In a polygon, the number of sides, vertices, and angle are equal. Okay, if you look at a uh, four sides, that is quadrilateral. So you can see there are four sides. The number of side is four. The number of vertices, the number of vertices is again 4, and the number of angle, if you look at the angle, what is the angle? 1, 2, 3, 4. This is again 4. If I were to draw another, for example, if I have to draw like here. Let's draw a, I don't know what is happening here right now. So if I have to draw another polygon, like if I draw a hexagon, now here you can see the number of side is 6 because it is a hexagon. If you look at the vertices, 1, 2, 3, 4, 5, and 6. So vertices is again 6. What about the angle? 1, 2, 3, 4, 5, and 6. Angle is also 6. Therefore, we can say that this is my true. Mhm. So we have learned that if the number of sides of a polygon is 4, then the number of angle and the number of vertices will also be 4. Also, if the number of sides of a polygon is 6, which is the hexagon, the number of vertices and the number of angles will also be 6. Therefore, this is my true. This is my false. I have already stated the reason. A polygon can have less than 3 sides. Okay, let's check this. Can a polygon has less than 3 sides? What is a polygon of 3 sides? It's a triangle. Now, can I have a polygon of only 2 sides? If I draw a 2 side, like this will be my 2 side. So this is my open figure, which is not a polygon. Means to become a figure to be a polygon, they have to be minimum 3 sides. Now, this is one of the criteria of a polygon, that it should have a total number of sides greater than 2. Then only it will be considered as a polygon. So this is my 4. Okay. Now let's see. Find the number of diagonal of a polygon of. Okay. There is a formula for this. Let's understand the formula. Total number of diagonal. Let's see. Total number of diagonals of a polygon is equal to n into n minus 3 upon 2, where n is the total number of sides of a polygon. Okay, now let's see. This is a formula that you have to remember. You have to memorize. Note it down. Just note it down. Just note it down. Note the formula. Because it is very important formula. It will help you in many questions. Now, if you look into the question, the question was find number diagonal polygon of 635 sides. Now look at, if I have to if I apply the formula, the total number of diagonal D will be n into n minus 3 upon 2. Here n, here n is equal to 35. So I'll apply the formula 35 into 35 minus 2, which is basically my 32. So 35 minus 3. So 35 into 32 upon 2. 16, 16 3 is a 480 plus 16 5 is 80. So it will be 560. This will be the total number of diagonals that will be there in this polynomial. What about the second question? The second question 60 sides. So I will also try to make you understand how to write in the language. So first thing, the question number, like this is the question number now, 1.3 B, 1.3 B. How to write 1.3 B? Okay, so how to write a question, how to write an answer? Here we'll write um, given. First we'll write what is given. Total number of sides equal to 60. Find total number of diagonal of the polygon. Now here let there be a polygon of 35 no 60 sides. 60 sides. We know that, what do we know? Total number of diagonals in a polygon is equal to n into n minus 3 upon 2. We have to mention what is n. We actually, whenever we write a formula now, we have to define each and every variable. Here only we have one variable, that is my n. So we'll only define n, where n is the total number of sides of the polygon. Okay, this is how you'd have already defined. Therefore, let's see, let's denote this by d. So we'll not write the whole sentence, we'll just write here d. D is equal to, what is the value of n? The value of n is 60 into 60 minus 3 upon 2. It is basically my 30 into, I will write here 30 into 57. Now 5 3 is 150, 7 3 is 21, 171, 0. This will be the total number of diagonals. So you can also write here, hence the number of diagonal of polynomial having 60 sides is 1100, 1710. Okay, this is your answer. Now you can write it. If you want to take a screenshot and you can write the whole solution. Now, what about the next question? So we got the answer here. The answer was 560 here, and the answer was 1710. Now, if you look into the question, okay. So if you look into the question, classify each of the polygon according to the number of sides, straight and regular and irregular, and concave and convex. See, one of the trick of finding a concave and a convex now is, like, if you see, let's draw it here. Let's draw a polygon. Let's draw another polygon. Hmm, this is my another polygon. Now see, just observe that if one of the angle is more than 180 degree, it is a concave. If you are finding difficulty in understanding this now, just locate the diagonals. Like here, what are the diagonals? This is one of the diagonal. Let's draw it by another line. Now this is one of the diagonal I am having. Okay, and this is another diagonal. Now see, if you observe that both the diagonals are going from the inside, मतलब वो आपके इस enclosed figure के अंदर है, चाहे ये इस फिगर के अंदर है। यहाँ पे अगर हम डायगोनल्स देखते हैं, ये तो आपका अंदर है, ये भी अंदर है, ठीक है। बट इफ यू सी दिस डायगोनल, ये जो डायगोनल है दिस इज आउटसाइड। नाउ सिंस जैसे ही कभी आपको कोई डायगोनल मिल जाए ना जो बाहर हो पॉलीगॉन के, समझ जाओ कि ये क्या है आपका कॉनकेव, एंड दिस इज माय कॉन्वेक्स। ओके, अब हम लोग यहाँ पर इसी लॉजिक को विल अप्लाई हियर। सी, कलर हियर, लेट्स सी, ऑब्जर्व करो, यहाँ पर एक एक डायगोनल है जो ऐसे है। In this diagonal, this is outside the polygon ना, therefore this is my concave. Okay, again यहाँ पे देखो, look at this diagonal, this is outside, this is also outside, means this is again concave. Here all the diagonals are inside, all the diagonals are inside. See, basically all the diagonals are inside means it is a convex. If you look at this again outside, this is concave. So understood the concept of concave and convex. Let's rub this. Now see, uh, first is the polygon according to number of its sides. Okay, number of sides. Now if I talk about number of sides, then 1, 2, 3. This is 1, 2, 3, 4, 5, and 6. So first thing that I understood that it is a hexagon. The second thing is uh, side, check whether it is regular or irregular. Okay, look at this side and look at this side. These two are not equal means this is irregular. What about the next thing? Concave or convex? We have already said it is a concave. Similarly, this is again my irregular. Okay, first thing that we needed to understand is the number of sides. 1, 2, 3, 4, 5, 6. Again, it is a hexagon, irregular, and it is again concave. Just pause the video and find about these two. Okay. Okay, let's see if you are correct or not. Now, since this is 1, 2, 3, 4, 5, so it is a pentagon. Now, the second thing that we need to know is it a regular or irregular. 1, 2, 3, 4, 5, 6. All the sides are my equal, so it is a regular. What about the next? Is it a concave or convex? Simple. If it is a regular, it is a concave. Sorry, convex. Convex. Now, when a polynomial is when a polygon is concave, it is simply irregular by nature. Number of sides 1, 2, 3, 4, 7. 7 sides, so it will be called as a heptagon, irregular. And what about a concave or convex? It is a concave. Concave. So One thing that we understood now, a concave polygon can never be a regular polygon. Okay, if we can, if I have to write it in the language, but we learned that a concave polygon can never be a regular polygon. Okay, understood this? Now let's come to the next question. Use the formula to find the number of diagonal surfaces of the following. A convex hexagon. A convex hexagon. Okay, one more thing. We look into the number of diagonals. Okay, let's draw uh, two polygons. Let's draw it here. So let's draw first one. Let's see. This is mine. I will draw a pentagon only. 1, 2. Let's draw a hexagon. 3, 4. Okay, pentagon. Okay, leave it. Let's try pentagon only. And again, if I have to draw a pentagon of a concave nature, 1, 2, 3, 4. Let's take it and it here. 4, 5. Okay. Hmm. You will get confused. It is my concave. Okay. Now let's see the number of diagonals. In this, how many diagonals we can have? First is my this 1, 2, 3, 4, and 5. What about this? 1, 2, 3, 4, and 5. So you can see the total number of diagonals remains the same. So whatever the formula for we have for this polygon, the same formula, n into n minus 3 upon 2, the same formula will be used for this polygon as well as this polygon. Understood? Now see, the question was, the first question was a convex hexagon. If you have to find the value formula for a convex hexagon, total number of sides is 6. Simply we can say, let's see, we'll draw it here only. The n is equal to 6. The formula is n into n minus 3 upon 2. That is 6 into 6 minus 3 is 3 upon 2, which is basically my 9. Okay, this is how you will calculate the rest of them. The next question is equilateral triangle. In equilateral triangle, it is a regular polygon by nature because all the sides are equal. So how can we find the value or the total number of diagonals? Here the n is equal to 3. The formula is n into n minus 3 upon 2. That is my 3 into 3 minus 3 upon 2, which is my 0. This is equal to 0 because 3 minus 3 is basically 0. Anything multiplied or divided by 0 is 0. So this is your basically 0. Now if you look at closely, so what is diagonal? What was the nature? What is the characteristics of a diagonal? It was a straight line that connected two non-adjacent vertices. Now this is a vertex, this is a vertex, this is a vertex. If you can see, all the vertices are adjacent to one another. Like this is A, this is B, this is C. So here A is adjacent to B as in C. If you look at C, C is adjacent to B as well as A. If you look at B, B is adjacent to A as well as C. Therefore, all the all the vertices are adjacent to one another. So total number of diagonal will be 0. Okay, this is rest. I will leave it up to you. Concave heptagon. Heptagon n is equal to 7. So here 7 into 7 minus that is 4 upon 2, which is basically my 14. Okay, this is how we'll find the values. Now let's see. Draw a polygon given above and the diagonals. Okay. Now just draw a polygon, like count and check. Okay. As you said. Let's see. Let's draw a concave heptagon. Let's draw a concave heptagon. I took the first one, I think. Let's see. Heptagon means 7 sides. A concave. So this is my first side, one side, two sides, three sides, four sides, five sides, six, and this will be my seven sides. Now total number of sides are 7. Now let's see. This is my A, B, C, D, E, F, and G. Now if you look into the diagonals, what are the diagonals here? This is 1, this will be 2, this will be 3, this will be 4. Let's draw it. Let's draw the number of diagonals here. This is 1, this is my 2, this is my 3, this is my 4. Okay, we have connected it. Now this will be my 5, this will be my 6, this will be my 7, this will be my 8. Now what about this? Okay, I can see here this will be my 9th, this will be my 10th, this will be my 11th. Okay, we have connected almost. Okay, now one is this 11. Okay, yes. Now this will be my 12th, this will be my 13th, and anything else? No, and this will be my 14th. Now, if you can see, each and every vertex is having 4, because if you look at total, the first total number of diagonal is 14, and we have already calculated total number of diagonal was 14 now. By formula, what was the formula? N into n minus 3 upon 2. So 7 into 7 minus 3 upon 2, which is my 14. Now, if you can see, in a heptagon, that is total number of sides is 7. So if you look into every side, like for G, if I have to look find out for G, the adjacent vertices are my A and F. So leaving these three, I have 4 non-adjacent vertices B, C, D, E. This is applicable for each and every vertex. So therefore, there are 4 diagonals for each and every vertex. Okay, this is how you can also find. Now, let's see. What was the next question here? I think that we have found a few things. Now let's come to this. Observe the concave polygon drawn in part B. What can you conclude from the observation? Now the things that you can conclude in this, these are the concave now. This is one of the concave. Regular again concave, octagon. Okay, and convex, convex, convex. Okay, okay. So we have only two concave structure. The first thing that we can see is the the angle. This angle, if you talk about this angle, now this angle is more than 180 degree. Okay, what else? The total number of diagonals is 14. Means the formula for the regular polygon is applicable for the irregular polygon. And the other things that we can see in a concave, there are first one angle, like if you see E, let's take this angle 1. So angle 1 is greater than 180 degree. मतलब one of the angle is greater than 180 degree. Diagonal is 14. Side is equal to 7. Vertex is 7. And what else? Let's see. The angle is equal to 7. Uh, each means each vertex is connected to 4 non-adjacent vertex. Okay, this is one of the observation. Rest, if you find any other observation, please let me know in the comment section. Now, can a concave polygon be a regular polygon? We have already discussed about this. A concave polygon can never be a regular polygon. Why? Because all the angles, all the inferior angles are not equal. Now, a regular quadrilateral PQRS is divided by its diagonal onto 4 sides. Okay, into 4 triangles. H1 is okay. We have to find the value of angle A, angle B, angle. Okay, ठीक है. So this is regular polygon. Okay. Now if you see here, if this is a regular polygon, means this side, sorry, this side SR will be equal to SC. Means the sides these two are equal, then the angle will be also be equal. Let's take this as triangle. This is my triangle. This is my triangle. Now this is my S, this is my R, this is my P. Now if you see that these two are same, if these two are same, then the angle opposite to this side will be equal to angle opposite to this side. Means this angle will be equal to this angle. If these two angles are equal, okay, this angle is equal to this angle. Also similarly, sorry, I mean that means this angle is equal to this angle. If you look into this, so therefore we can say that if we look into this triangle, then we can find that this angle is equal to this angle. Okay, now what else? Again, this angle will be equal to this angle, and this angle will be equal to this angle. Now, since it is a regular polygon, okay, since it is a regular polygon, this angle will be also okay. It can be easily identified. Okay, see, we don't need anything. This is straight line now. So it is diagonal. It is a straight line. A straight line is always 180 degrees. This is straight line, and if one of the angle is 90 degree, means if I have to say this is my straight line and this is a line. Now if one side is 90 degree, then this side will also be 90 degree because it is a straight angle. So this angle, if you look at this angle is my 180 degree. Okay. Therefore, if this angle is my 90 degree, then I can simply say this angle will be my 90 degree. Okay. If this angle is my 90 degree, this is again straight line. Means I can say this angle is my 90 degree and similarly this angle is my 90 degree. Now, if this is my 90 degree, okay, let's see what I mean to say now. Now, take a theta one. Now, if I'm saying, if this is my 90 degree, why? Because this is a straight line. Okay, this angle is 90 degree, this angle is also 90 degree. And we have already know that this side will be equal to this side. Now, means this will be my 45 degree and this will be my 45 degree. Similarly, this will be also my 45 degree. This will be my 45 degree. This is my 90 degree. This is my 90 degree. This is my 45. This is my 45. Okay. Hmm, let's see. Hmm, what is this? Can a triangle be a concave polygon? Can a triangle be a concave polygon? No, a triangle cannot be a concave polygon because we cannot construct any triangle. Why? To be a concave polygon, the minimum number of sides should be 4. Like this is a triangle, na? So this has only adjacent vertices. So therefore, it cannot be a regular polygon. If you have to construct a concave polygon, so this is a concave polygon. This is 1, 2, 3, and 4. See, this is my more than 180 degree, and this is my concave polygon. So this number of side n is 4 here, n is equal to 3. You can write the language like since a triangle consists of only adjacent sides, therefore it is not possible to construct a concave or concave triangle. Okay, a triangle is always a convex because if you talk about a polygon, it is an enclosed figure, and if you have to draw a triangle, this is a triangle, na? So this is my okay. You can also add one of the reason, one more reason that I am getting here now. See, what is the total sum of all the angles of a triangle? Hmm? Here I am finding one more reason, and this will be much more relatable. Like this will be to the point. Leave it. Okay, leave this. Let's see. See, since a triangle, since in a triangle,